So what I'm saying is differentiation is subtraction, and in differentiation we have UV product rule, we have U by V division rule.
Yes.
And we have differentiation of so many functions: sin x, cos x, e power x, differential of log x, and that's all fine. But where is practically differentiation used for is what we have to understand. Okay, so let us say that displacement of a body, of a particle, is given as a function of time. Or let's say the instead of displacement, let us take nahi, sahi hai, displacement is sahi. Displacement is given as a function of time as t cube minus t square plus 2t 4. Okay, या फिर plus 2t कर लेते हैं because I said it is. The displacement of a particle is given as s is equal to t cube minus t square plus 2t.
Yes.
The velocity, find the velocity. This is the question. So simply,
displacement is equal to time into velocity, right?
So the definition of velocity is rate of change of displacement, ds by dt.
Okay.
So simply you can differentiate it and divide by dt, and I know you can give the answer, right?
And 3t square minus 2t plus 2.
Right. So now basically he will say find velocity of this body at t is equal to 3 seconds. Okay.
I'll just substitute.
We just substitute 3 seconds over there. So
3
velocity at 3 seconds is
6 plus 2.
27 minus 6 plus 2
23.
is 23. Let's say meters per second. Correct?
Yes.
Now I will show basically what we are looking at is how do I practically apply this calculus in some realistic terms. Okay, so for example, I have a circle. Okay, a circle of radius r. Okay, there is a circle of radius r such that the condition, see, in our questions always there is always a condition that is given. In the earlier question, the condition was displacement is this.
Yes.
And find velocity at this. So time 3 seconds is one of the conditions, and the displacement
is this function
that is given. तो वो particular condition पे मुझे बताओ कि क्या है. अभी मैं बोलूँगा displacement is sin t, तो फिर तो कुछ आंसर अलग आएगा.
Yeah.
So basically conditions are there, and using those conditions we are told to find something. Are you getting my point?
Yes.
So I want to eat Domino's pizza and I want to find the nearest Domino's. So what I'll do, I'll basically go somewhere, ask someone, he will say certain place. I'll go there in that particular building. I'll find the condition. I have a particular staircase, so I'll climb the staircase. If I have a lift, I'll get into the lift. If it's on the ground floor, then the condition is walk like this and you go over there. In any kind of a problem solving, we always have conditions. Therefore, in mathematics, especially in calculus, you will see this word coming again and again. In physics, we have the same thing, but people do not put it straightforward that this is a condition. Okay. Wherever calculus is used, you are having condition. Without condition, there is no calculus. You can solve other problems where you do not have conditions per se, other chapters, questions that you can solve without, let's say, condition. Mostly every question that we solve, every chapter, maths, physics or chemistry has conditions, mostly, but specifically any calculus related will definitely have conditions. You have to have this in your head. Okay. So I have a circle of radius r, great, such that the condition that is given is the rate at which the radius is changing, the rate of change of radius. This is how we'll specify it in English. Rate of change of radius, or rate at which the radius is changing, which is mathematically nothing but dr by dt. The rate at which the radius is changing is, let us say, 2 meters per second. Then he will ask, so this is the condition that he is given. Then he will ask, find the rate at which the area is changing. Find the rate of change of area. Now, in certain questions, there will be some basic information which we usually might have got it in school. So therefore, he will not specify it in the question. This is one of the scenarios like that. Find the rate at which the area is changing. So I know from my school knowledge that area is pi r square.
Pi r square.
That means I have conditions given in my question. Now I need to get some kind of a equation.
Yes.
Equation in the previous question was given because that was the situation over there. Here he doesn't have to mention me a is equal to pi r square because I know it with my school knowledge.
Yes.
Once I got the equation, I don't know what I am doing. Somebody taught me differentiation, I'll differentiate. Let me not know what I am doing. I don't bother, not bother.
So just differentiate pi r square?
When you have an equation and you know that you are in calculus, always, even if you don't know the sense of it or meaning of it, go for a differentiation. The differential of a right side will be what? 2 pi r dr. And if I divide dt both sides, it will look like this.
Why is it 2 pi r dr?
Differential of a is differential of pi r square. R is a constant, which is pi differential of r square, which is pi differential of r square is 2r dr. Therefore, it is 2 pi r dr.
Oh, okay.
Right?
Yes.
Okay. So also in the question, we need to give, let us say, at r is equal to 6 meters. The dr by dt, rate at which the radius is increasing. So maybe it's something like I am pouring water on the ground and the rate at which the radius is increasing, and assume that the water is making a circular shape. The rate at which the radius is increasing is given, and he wants us to find the rate at which the area of this radius is increasing. This is the area it will increase, right? Once I'm increasing the radial,
yes.
So the circle basically is going to increase this way. So simply substitute the given things, conditions over here. So I have 2 pi, r is given as 6 meters and dr by dt is given as 2 meters per second. So basically I'll have 24 pi meters per second. Meters square per second, sorry.
Okay.
Because 1 meter is coming in my dr by dt and the other meter is coming in my r. So meter square per second.
Yes.
Now I'll give you a question. Even if you don't get a proper sense of it, just like I said, identify if you have knowledge of any equation related to that particular thing and just differentiate and see if you can get it. So the question is simply this. So we can make a story also out of it. I have a cylindrical vessel and I am pouring water into it. I have a cylindrical vessel and I am pouring water into it. Okay. The radius of this vessel, take it as 1 meter. Radius of the vessel is 1 meter. Yeah. Because I am pouring water in this cylindrical vessel, obviously radius तो बदलेगा नहीं, वो vessel है, radius same रहेगा. Height of the water level will increase. Let the height be h. Okay. And it is given that it is seen that the rate at which the height is varying is also 1 meter per second. I am giving all one values so that calculation में फिर ज़्यादा मेहनत नहीं रहेगा.
Okay.
So I am pouring water into a cylindrical vessel. I am pouring water in a cylindrical vessel. The radius of the vessel is 1 meter. The height of this water level is given as h. Obviously, it's a variable, it's not a constant. And the rate at which the height is increasing is seen as 1 meter per second.
1 meter.
Is found to be. So simply he will say find the rate at which the volume of the water is changing. Or I can put the question in a different way. Find the rate at which I am adding the water.
Okay.
वो भी वही होगा ना. The rate
Yes.
at which I am adding the water into the vessel is the same rate at which the volume of the water in the vessel. Both are same. It's a cylinder.
Yeah, pi r square h.
So radius is anyways a constant. So what's the next step?
Differentiate pi r square h.
So simply I'll have this radius is also a constant. Now divide dt and dt.
Pi
meter cube per second. The rate at which the volume is changing. Radius is also 1 meter.
What happened to dh?
dh by dt is 1 meter per second.
Oh, that's where I went wrong. Yeah, I didn't take the 1 meter per second.
There's nothing wrong in it. It's just you didn't identify. You're not habituated with these. That's all. How is there a possibility to do something wrong when there is nothing available over there to do? Okay. Now again, it's the behind the story that I am making up is, we can make many stories of this. There is an air bubble.
Okay.
I am pumping an air bubble with some gas, whatever. Obviously, when we say air bubble, he will not mention, but you should know it's a sphere.
Sphere.
Now, it is given that the rate at which, and we are blowing air into it, this is all part of the story, okay? It is given the rate at which the radii is varying. See, he will not directly tell you this is dr by dt, he will tell you in English.
Maths.
अंग्रेजी में बोलेगा. The rate at which the radius is increasing or the rate at which the radius is decreasing, that's how he will put it. So the rate at which the radius is increasing, dr by dt, is given as 3 meters per second.
Okay.
Find the rate at which the volume is increasing when the radius is 2 meters. So instead of you solving, tell me where to start.
First, volume of a cylinder is 3 by 4
It's a
pi r
sphere.
cube. I meant sphere. 3 by 4 pi r cube.
4 by 3 pi r cube.
Oh my god.
तो कहते हैं focus.
4 by 3 pi r cube.
Tell me the next step.
Differentiate 4 by 3 pi r cube. सब कुछ तो constant है.
Fast.
So 4 by 3 pi. No. Pi r cube becomes 3r square. So 4 pi r square.
और क्या? Whenever you differentiate, you will get a
Yeah, dt.
dr. ठीक. हाँ, ध्यान किधर है? ठीक है?
Yeah.
4 pi r square dr. Then do what? Divide dt on both ends.
Yes.
Now just substitute. 4 pi, radius is 2 meters square, dr by dt is
12 pi r square.
48 pi meter cube per second.
और रेडियस की भी वैल्यू सब्स्टिट्यूट कर रहे हैं.
R is 2, right?
Yeah.
2 square is 4, dr by dt is 3, 4 4 is 16, 16 3 is 48.
Yeah.
Fine?
Yes.
Let's make some other story. See, these are all, we are using geometries that we have knowledge of from our school only, right?
Yeah.
I'll dictate you this question. Let's see how you do. Okay. 5 rupee coins.
Yes.
5 rupee coins. I don't know how this symbol comes, like this, something like this. And also there's something like
Lines, yeah.
5 rupee coins are being stacked upon each other
Cylinder.
to form a cylinder.
Yes.
Okay, you'll have to, because I am giving this to you, so basically you'll have to think it a little bit, and if you want, draw a figure, imagine a little, and you'll have to use your intuition.
Yes.
It's not like कि हाँ मुझे आता है तो हो गया, ठीक है? 5 rupee coins are being stacked upon each other to form a cylinder.
Yes.
The thickness of each coin is 2 centimeters. The thickness of each coin is 2 centimeters. If 5 coins are stacked per second, if 5 coins are stacked every second, find the rate of change of volume of the cylinder that is made.
In how much time? In 2? No.
Find the rate of change of volume of the cylinder that is made when 50 coins are stacked. So I'll completely.
So 10 seconds.
So 5 rupee coins are stacked on each other to form a cylinder. The thickness of each coin is 2 centimeters. If every second 5 coins are being stacked, find the rate at which the volume is varying when 50 coins are stacked at a situation where 50 coins are stacked. Okay. So volume of the cylinder is pi r square h.
The rate is 20 pi. So when 50 coins are there.
No, it doesn't matter. I think that is an extra information. So you just get it like this, right? dv by dt is pi r square into dh by dt. So simply we can substitute it over here. 1 centimeter.
It's 2 pi r dh by dt, right? Is it not?
2 pi r will give us perimeter, right?
No, v is pi r square, but dv by dt.
But r is a constant.
R is a constant?
Every coin has a constant radius.
Okay.
dh by dt is what? 10 centimeters per second, right?
Yes. Pi r square.
So we have 10 to the power minus 5 pi meter cube per second.
The radius is 1 centimeter.
10 power minus 2 meters whole square is 10 to the power minus 4. One centimeter is 10 to the power minus 2 meters.
Yeah.
And you have square of it, so 10 power minus 4.
Oh, finding the answer in meters cube per second.
Fine?
Yes.
I'll give a simpler one. The rate at which the side of an equilateral triangle, where A is basically the side of an equilateral triangle. So the rate at which the side of an equilateral triangle varies is, take it as 3 meters per second.
Okay.
Find the rate at which the area of the triangle is varying when the side is 10 meters.
Area of an equilateral triangle is root 3 by 4a square. Side is varying, right? So it's not a constant.
You have written the equation. Area is equal to root 3 by 4 a square. What is the next thing that you need to do?
Differentiate it.
So tell me what is the next step that I'll get. dA is equal
root 3 by 2a.
Root 3 by 2a.
D.
Always you get a differential element whenever you differentiate a variable. I have told, this is one of the reasons why I told you that. One of the reasons why I always say you will always get a differential element whenever you differentiate.
Yes.
Now, next step is what?
Now you calculate the rate. So dA by dt.
Just divide this by dt. And the next step is?
Root 3 by 2a dA by dt. dA by dt is 3. So 3 root 3 by 2a is the dA by dt.
And a is also present here. In the place of a, you will substitute 10. In the place of dA by dt, you will substitute 3. Right? So basically, we will have 15 root 3.
30 root 3 by 2, which is 15 root 3.
Meters square per second.
Yes.
I'll give a similar type but different geometry. 125. A rectangle having a, so this is a rectangle having length L and breadth B. Such that the rate at which the length is varying is 2 meters per second. The rate at which the breadth is varying is 3 meters per second. Find the rate at which the area of the rectangle is varying at L is equal to 5 meters and B is equal to 6 meters. Find dA by dt when L is equal to 5 meters and B is 6 meters. Okay, we'll solve it together. You tell me how to do it. Okay, what should I write first?
Area's length into breadth.
What should I do next?
Differentiate area. So D, LBD plus BLD.
Good. LDB plus B.
And then the differential element is, I don't know what.
VDL. Right? Product rule. You basically know the product rule. What do I do next?
You have to add a different, you said you divide it by time.
Divide by dt on both sides. So next, dA by dt is equal to. Bolo.
Oh, okay. I didn't divide them both by dt.
Okay, bolo. Next.
You substitute the dl by dt and dv by dt.
Bolo kya hai?
2 and 3. So it's going to be 3l plus 2b.
L is what?
Length.
5 meter, right?
Yes.
Oh, you are saying कि वैसे सर 2l plus 3b. L भी तो substitute कर लो ना फिर.
Then it's just going to be 15 plus 12.
So 15 plus.
27.
How is it 15 plus 12?
If you substitute both the value of dr by
ओहो,
dt and
ये
ln,
उल्टा लिखा अपन ने. हाँ, आप मेरे को ही कंफ्यूज. बढ़िया है. हाँ जी, अब सही है. तो 15 प्लस 12.
हाँ,
So it is 27
27.
meter square per second.
बस.
Simply तो चलिए 126. So you start off with the equation that you have knowledge about. Start differentiating. In rate or whatever, in these type of questions, you just have to divide by dt.
My biggest problem is the differential element को recognize नहीं कर पा रही हूँ. उसका जैसे मैं पूरा करना चाह रहा है. Every single time
ज्यादा. इसको corruption बोलते हैं. That means कि you are forgetting the fact that we started with. You should get a differential element. You should write a differential. Corruption दिखता है उसमें, but ठीक है. चलिए 126.
Yes.
Again, I'll give a different way of looking at it. So I have a square. I have a square, and the diagonal of a square is represented by d.
Okay.
So find the rate at which it is given that the rate at which the diagonal is varying is 2 meters per second. Find the rate at which the area of this square is varying.
Diagonal, wait, area of a square from diagonal is what? Root 2, no, diagonal का side से कुछ है, root 2s, something like that.
वो कर लो आप, टेंशन थोड़ी है. आराम
मुझे
से,
याद नहीं.
वो आराम से करो. Find the rate at which the
Pythagoras theorem.
Find the rate at which the area is varying when the diagonal is given as 3 meters. ले लो. तो अब आप लगाओ अपना दिमाग.
मुझे फॉर्मूला नहीं याद है.
तो सॉल्व इट फ्रॉम द स्क्रैच. जो फॉर्मूला आपको पता है उससे शुरू करो ना. टेक दिस.
Pythagoras theorem.
करेक्ट.
So d square is equal to s square plus s square is equal to s to the power 4.
S square plus s square is s to the power 4.
It's 2s square, never mind. होता है. Okay, so d square is equal to, okay, so d is root 2s square.
सुनो,
So it's root 2s.
मेरी बात तो सुन लो एक बार.
I was right.
You are right. बट एक बार सुन लो मेरी बात.
हाँ.
तो suppose Iron Man went x meters ahead, then took a left turn and x meters.
Yeah.
Of course, took a left means 90 degrees. So how
Yes.
much will this be? It will always be x root 2. Because you're always going to do x square plus x square, which will be 2x square, which is x root 2 always.
I thought that, but then I was like, maybe I'm wrong.
चलिए, all the best.
Okay. Area of a square is side square. And side is diagonal by 2. So diagonal by root 2. D by root 2 whole square is equal to d square by 2. है ना? So area of a square is d square by 2.
हाँ, समझ गया मैं. आगे बढ़ो. गलत है तो बोलूंगा ना गलत है. ऐसा थोड़ी है कि गलत कर रही है फिर भी मैं नहीं रोक रहा हूँ.
Now differentiate d square by 2. 2 is constant. So 2d by 2.
Whenever you differentiate, you will.
2d by 2 नहीं क्या होगा डिफरेंस? क्या ढूंढ रहे हम लोग? dd नहीं.
हाँ.
नहीं. हाँ.
हाँ.
हाँ. Yeah, that is what it is. Okay, so dA by dt is equal to d square by 2 dd by dt. So 2 gets cancelled, d square.
सीरियसली dd को आपने d into d कर दिया है?
नहीं.
When you write dA by dt, then you should get a differential element on the right hand side.
No. d by dt is 2. तो मैंने उसकी वैल्यू सब्स्टिट्यूट करके 2 कैंसिल किया. That's why it's d square. dA by dt is d square. D की वैल्यू 3 है, so 9 meters. I think.
Close your book.
लेकिन that can't be right. I don't think it's right.
Close it. उसको बंद कर दो. इससे ज्यादा कचरा पॉसिबल ही नहीं है.
I don't know what I did.
Okay, tell me. A is equal to
d square by 2.
Next step. D square by 2, yeah. Next step.
dA
is equal to
2d by 2 dd.
ठीक है, 2 तो यहाँ cancel.
It's 2d by 2 dd. Okay, never mind. I know what I did wrong. मैंने इस चक्कर में डिफरेंशिएट करना भूल गई मैं. हाँ. They're so smart. 6 answer.
Sand is being poured on the ground.
Okay.
From the top. Okay. And the sand on the ground takes a shape of a cone. I could have said it, I have a cone, but ऐसे थोड़ा background story बना के.
Yes.
The cone that is made is seen to have a fixed angle 30 degree. That means this 30 degree is always the same irrespective of how much.
There's a formula for finding the angle of a cone. हम लोग ने apply नहीं किया था कहीं पे भी. I forgot it.
Problem यही है कि आप भाग जाते हो कहीं.
Okay.
को पकड़ना पड़ता है. ऐसा कुछ करना नहीं है. Now, the cone angle that is shown in the figure is a constant irrespective of how much ever sand you pour. So you're pouring sand, so the cone is increasing in size, but the angle is the same.
How does that happen?
Given that the angle is the same. Okay. Take the radius of the base of the cone to be r and the height of the cone to be h. Okay. It is given that the rate at which the radius of the cone is varying as the sand is poured is 2 meters per second.
Okay.
Fine?
Yes.
Find the rate at which I am going to solve this question. So, find the rate at which the volume of the cone is increasing, or he can also say the same thing, that find the rate at which the volume of sand is being added. The volume of sand that is added per second is the same as the rate at which the volume of the cone is increasing. Correct? Find the rate at which the volume of the cone is increasing when the radius is 6 meters. I'll solve it.
Okay.
So how am I going to start with it?
Volume का formula 1/3 pi square h होता है for a cone.
या तो किताब बंद करो और मुझे बताओ, मैं यहाँ करूँगा.
1/3 pi square h is the formula for volume of a cone.
बंद तो करो. There's a difference between closing और खोलना नहीं उसको. ठीक है? So volume, you were right. We will start off from 1/3 pi r square. Okay, fine.
Differentiate करेंगे volume को.
Correct. But there is another condition given in this question.
30 degrees कहाँ से आ रहा है? What do you do with that?
So what do you think this 30-degree story is given for?
Solid angles, radians. I don't know.
Who taught you all these bullshit? Solid angle किसने सिखाया आपको? मैंने तो कभी नहीं बोला है भाई. So understand one thing कि आपको यहाँ पे R है और H भी है. लेकिन क्वेश्चन में सिर्फ dr by dt.
R है, so we have to find H.
हाँ.
Then how will we find H?
How will I find H from this 30 degree?
Angle दिया हुआ है इसलिए.
Good.
Some kind of arc or something is being formed.
Arc is formed. वाह, मतलब इसको एक जगह से कहीं और.
I don't know.
In terms of R, things are given. You need to find H. Looking at this figure, can you make something out of it using the 30 degrees?
Trigonometry कर रहे हैं हम लोग.
चलिए एक कदम बेबी स्टेप तो लगाया आपने. हाँ.
नहीं, that was my first thought, but then I was like, कौन है तो उसमें trigonometry कहाँ से आएगी? Because it's like it's 3D.
इसलिए मैंने from this figure बोला है ताकि आपको हिंट भी मिले कि इसी से बताना है, जो इधर दिख रहा है उसी में से. मैंने कौन नहीं दिखाया यहाँ पे, बट ठीक है. चलिए. So what?
What do we find? Tan की value.
Good. So tan 30 बोलिए.
Tan 30 is 1 by root 3.
वो तो पता है. यहाँ फिगर में क्या आएगा?
H by R. नहीं. Tan 30 R by H.
R by H. और हमें क्या चाहिए? We want H because H दिया नहीं.
So H is R by tan 30.
H is equal to R by tan 30.
So root 3R. H is root 3R.
R root 3. ठीक है, बढ़िया. Next, what should I do?
Substitute. I mean, I differentiate then substitute.
Substitute because H पता नहीं है. अभी मैं differentiate करूंगा, दो लोगों को differentiate करना पड़ेगा. Substitute करके differentiate करूंगा तो एक ही को करना.
Okay, तो R को substitute करेंगे H को?
You decide.
R is easier ना कि it's a whole number.
A whole number.
Like it's 6 meters. I mean, it's 2. नहीं. हाँ? What am I saying? कुछ समझ नहीं आ रहा.
चलिए देखिए इधर H को substitute कर लो. Although it really doesn't matter if you substitute R also, it will be correct only. समझ. प्रॉब्लम ये है कि मैं H को R के टर्म्स में इसलिए सब्स्टिट्यूट करूंगा क्योंकि R के टर्म्स में इंफॉर्मेशन दिया है भाई. मैं R में लेके आऊंगा ना. Why will I go to H? फिर इंफॉर्मेशन को H के टर्म्स में लेके आना है. क्यों मेहनत करना है? Right? So next step is this root 3 by 3 will become denominator root 3. So pi by root 3 R cube.
Yes.
What is my next step?
Differentiation.
चलिए बताइए.
Oh God. 2 pi R square by root 3.
dv is equal to
3 pi. It's what? 3
LHS.
3 pi R square by root 3.
आप मेहनत ज्यादा करते हो. LHS तो dv बनेगा ना.
So हाँ.
इतना तेजी से आप करते हो, मैं थोड़ी कैच कर पाता हूँ. फ्लैश हुआ. चलिए.
It's root 3 pi R square d.
मुझे तो pi by root 3 दिख रहा है तो पहले वो लिख लूंगा. करेक्ट है क्या?
हाँ.
क्योंकि मैं आपके तरह तेजी से नहीं जा सकता. हाँ जी. अब बताइए.
3 pi R square dt.
3R square.
हाँ. d differential element dv का dr.
dr. अब क्या करेंगे नेक्स्ट?
Divide by dt.
चलिए बढ़िया. एंड नेक्स्ट?
Substitute value of dr by dt, which is 2. So 6 pi. हाँ. 6R square.
6 square. R itself is 6.
नहीं, मैं तो 3 और 2 को मल्टीप्लाई कर रही थी.
ओके, वो भी करेंगे. R के जब R स्क्वायर दिख रहा है ना मुझे नेक्स्ट,
तो 36.
मुझे और आगे दिख नहीं रहा है. हाँ 36. और dr by dt is ठीक है.
हाँ.
dr by dt is 2. हो गया पूरा सब्स्टिट्यूशन.
तो 216.
ठीक है, अपनी मर्जी है. ये इसको रूट 3 कर सकते हैं. 36 2 is 72 रूट 3 पाई. नीचे एक रूट 3 है ना. 216 by root 3 भी वही आएगा.
Yes.
सही है?
Yes.
Xerox. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.